This is our last video in the series dealing with reaction types. In this video, we're going to look at synthesis and decomposition reactions. Both of them are very similar to each other. They're just going in opposite directions. So synthesis and decomposition reactions aren't classified as redox reactions specifically because they can occur without having a change in oxidation state. Synthesis reactions are easy to identify because you're going to have one compound form from multiple atoms or compounds. Decomposition reactions are just the opposite. You're going to have one compound and it's going to break down into multiple elements or compounds. Basically, synthesis and decomposition reactions are opposites. Let's look at synthesis reactions first. The general format is pretty simple. You get A plus B giving you C. You could actually have more than two reactants, but we're going to keep it simple and mainly deal with reactions that involve only two reactants giving us one product. An example would be ammonia and hydrogen chloride. When these two compounds react, they're going to form what we call ammonium chloride. Another example would be calcium oxide and water. When you place calcium oxide into water, you're going to form calcium hydroxide. Now those are somewhat complex reactions. The reactions that you're going to need to be able to predict are going to basically involve just elements. So sodium and chlorine, when they react, the only thing they can do is come together to form a compound, in this case sodium chloride. And we would balance that reaction to make sure that each atom has the same number on both sides. Another example would be magnesium and sulfur. Magnesium and sulfur are going to combine to form magnesium sulfide. Our last example would be aluminum and oxygen. Aluminum and oxygen are going to react to form aluminum oxide. In this case, our subscripts are completely different because the charges of aluminum and oxygen. You have to have those balanced for the formula to be correct. And the last thing we would do is balance the reaction so that you have equal numbers of each element on both sides. All of our synthesis reactions have one product. The ones that you're going to have to predict are going to involve elements, and those two elements are going to combine to form one compound. The only thing that you need to do is make sure that you have the charges for each of the elements balanced correctly in the formula to make the product correct, and then balance the reaction at the end. Decomposition reactions are basically just the opposite. Instead of ending with one product, we're going to start with one reactant. And that one reactant is going to break apart into two or more products. Ammonium hydroxide will decompose into ammonia and water. Hydrogen sulfite will decompose into water and sulfur dioxide. Hydrogen peroxide will decompose into water and oxygen gas. And when you balance the equation, you would need two hydrogen peroxides to balance that reaction to produce two waters and an oxygen gas. In a more complex reaction, that's decomposition, we have dynamite, TNT, and two molecules of that will decompose into 3 molecules of nitrogen, 5 molecules of water, 7 molecules of carbon monoxide, and 7 atoms of carbon. This is one of the reasons why dynamite, or trinitrotoluene, is such an explosive, is because it produces all of these gases from those two solid molecules. Now, the decomposition of binary compounds is just the exact opposite of the synthesis of binary compounds as we saw earlier. Basically, you have a compound that's made up of two elements, and if it decomposes, it simply breaks apart into the two elements that make it up. In this case, sodium chloride is going to decompose into sodium and chlorine gas. The Cl2 has a subscript 2 on it because it is a diatomic molecule. And at the end, we balance the reaction. Magnesium nitride will decompose into magnesium and nitrogen gas. Again, the nitrogen is diatomic, so it has to have the subscript 2. And as a final touch, we balance the reaction. Potassium nitride decomposes into potassium and nitrogen gas. Again, we must at the end balance our reaction. Predicting the decomposition of binary compounds is just simply straightforward. take the compound and break it up into its elements.